Okay, here we're going to graph the equation x squared plus z squared equals 4 plus 2y squared in R3. So we'll start like usual. We'll plug in x equals 0 to get the trace in the yz plane. We'll get z squared equals 4 plus 2y squared. And recognize this hopefully fairly quickly as the equation of a hyperbola. We'll subtract 2y squared from both sides, and then we'll eventually want to divide through by the constant term 4 as well. If you can do all those steps at once and do them correctly, that's perfectly fine. If you're making mistakes, then write the steps out. Okay, so this is a hyperbola in the yz plane. This is going to open in the z direction, since z is our positive term, and it will intersect the z-axis at plus and minus 2. Square root of the denominator there. And then when I think about how wide or narrow this hyperbola is, I want to look at the ratio of the square roots of the denominators on the z and y terms. And so if I think about the square root of the denominator on the y term, I get square root of 2, about 1.4. And so I'm just going to put a little point here to help me draw in the asymptote. So I went over 1.4 unit in the y direction, or square root of 2 units more exactly, and up 2 units in the z direction. And then from the center of the hyperbola to that point that I plotted, I'm going to get a line, and that helps me see what the asymptote would look like. And I could do the same thing in the other quadrants of the yz plane. I'm just going to do this one part and then use symmetry to sketch in the rest of the hyperbola. So from my vertex here, we'll go toward the asymptote, and then I'll want to make the other side look about the same width. And then down here, similar thing on the negative part of the z-axis. Okay, and I'm going to go back in and try to erase, not erase the hyperbola, but instead I want to erase the asymptote. Okay, maybe I'll just try to redraw that hyperbola now. Okay, you don't have to erase those asymptotes, but when you're putting several things on the graph, it can get a little bit distracting if you have too many things going on. And remember that this hyperbola that I drew here is in the yz plane. We're going to go ahead and do another cross-section in the xz plane. Plug in y equals 0. We'll get x squared plus z squared equals 4. We'll recognize that as the equation of a circle in the xz plane. So we've got a circle with center at the origin, and it's going to intersect the x-axis at plus and minus 2 and the z-axis at plus and minus 2. Looks like I erased my scale on the z-axis when I erased the asymptote, so let me go ahead and put that back on. Okay, so that circle that we have in the xz plane intersects our hyperbola, where the hyperbola was crossing the z-axis at positive and negative 2. Drew the back side of that circle dashed. The surface that we're going to get here, the part going into the paper in the negative x direction, will tend to often be behind other things that I draw. So sometimes I'll start out by drawing that dashed and then go back in and fill it in solid if I want to. Or sometimes I'll draw it solid and then dash it, although with the computer it's probably easier to draw it solid, or draw it dashed and then fill it in solid. Okay, I'm going to plug in z equals 0 to get my third trace in the yz plane. I'm sorry, in the xy plane. So we'll get x squared equals 4 plus 2y squared. And subtract the 2y squared from both sides and then divide through by 4. We'll get x squared over 4 minus y squared over 2 equals 1 hyperbola in the xy plane. This hyperbola is going to open in the x direction. It's going to intersect the x-axis at plus and minus 2. And the asymptotes, I'm going to use 2 in the x direction and about 1.4 in the y direction, and kind of line that up to get the slope on my asymptote here. I'm not going to actually sketch in that asymptote because I've got a lot of other stuff here. And if I sketch that in on top, but I just kind of made my pencil go the way the asymptote would be if I sketched it, and then use that as a guide for where to put my hyperbola. And then doing the same thing on the back branch here. For these cross sections that are in surfaces or planes that are going into the paper or out of the paper, sometimes it can be a little bit difficult to get the angles on your lines correct. So sometimes it can be helpful to plot a few points on this. I maybe should do that hyperbola dashed since it's going back into the paper there. Okay, at this point, if we kind of think carefully about what we have these two branches of the hyperbola that I've drawn in green that are opening toward us in the xy plane, and then rotated 90 degrees from that and rotated up to the top of the z-axis and the bottom of the z-axis. I've got these other hyperbolas, pair of hyperbolas that are opening up and down. So if I just kind of think about that much, I sort of have this hourglass sort of shape, and then my circle that I've drawn in blue here is sort of like a waist or around the center of that hourglass shape. And this is another one where even though I got 3 good cross sections, it can be helpful to go ahead and draw some extra cross sections and kind of just thinking about the shapes that we already have and where they're headed. In the xy plane, I have this hyperbola, and as I come out farther in the positive x direction or farther in the positive y direction, I get larger and larger slices on that hyperbola. And so this overall shape is going to be widening as we come out in the y direction. So it could be helpful to plug in some positive value of y to help us get a little bit better idea on the shape of this graph. So I can choose whatever I want. I probably don't want to choose anything too close to y equals 0 because otherwise it'll be really bunched up. Y equals 2 might be good. I'm going to go ahead and go a little farther out and do y equals 4. Just so I can get a little bit more to the shape, and I can go ahead and do the -4 as well in the y direction. So plug in those values for y. I'll have x squared plus z squared equals 4 plus 32. Does that sound right? Or x squared plus z squared equals 36. So out here at y equals 4, we've got this circle of radius 6. So out here at y equals 4, if I go 6 in the positive x direction, and then 6 in the negative x direction, and then 6 in the positive z direction, and 6 in the negative z direction, and those should intersect with those branches of the hyperbola that I already drew. Again, depending on how carefully I plotted those points, they may or may not line up perfectly. We get this ellipse out here, and as y gets larger and larger, my ellipses will get larger and larger as well. What this sort of gives is sort of a bell edge to the bell shape that we've got here on this surface. If you can kind of think of the bell of like a tuba or something like that, where you've got a small part here, and then as you come out it gets wider and wider and wider. That's what we've got going on over here, opening on the y-axis. I'm just going to draw in some contour lines that are like the arcs of the hyperbolas here to make that look 3D. So we're clear about what part of the surface is coming out and what part is going back into the paper. This is just the right half, and then there's a similar thing on the left half where y is negative. Another thing to pay attention to over here, the y-axis is coming out of the center of this object. So this object is all centered around the y-axis. I could do some more shading or more contour lines maybe. Do another color here. And kind of make that look like it's going behind the y-axis there. Make it look rounded, perhaps. I don't know if that yellow helps or not, but sort of making it look like it's opening through the y-axis there. Make sure it's clear that that y-axis is coming right out of the center of that object. Okay, and then a similar thing in the negative y direction. So I'm going to go back here to y equals -4, and then from there I'm going to go 6 and -6 in the x direction. That green hyperbola that I drew on the back there, looks like I didn't quite draw that far enough. And up and down 6, and again my red hyperbola doesn't quite line up with where I would like it to. That's because I kind of just eyeballed it and used symmetry to sketch that hyperbola. So it doesn't have to be perfect. That's why this is called a sketch, not a perfect picture. Okay, but I'm going to use those points that I have, up and down 6, forward and backward 6. Use those to sketch in my ellipse. I'm sketching the back part of my ellipse here, dashed. That part we would be able to see actually. Back part of my ellipse that we would not be able to see, sketching that in, dashed. And I'm going to shade this here. I'm drawing some arcs. Make it clear that I have this bell shape. So I sort of have an hourglass sort of shape, or looks a little bit like a nuclear reactor kind of thing turned on its side. Think about those cooling towers in nuclear reactors, sometimes kind of look like this. And we wouldn't be able to see into the part that's in the negative y direction. That part would be opening along the negative part of the y-axis, so we wouldn't be able to see into that. This is called a hyperboloid of one sheet. We looked earlier at a hyperboloid of two sheets. Both of the kinds of hyperboloids have hyperbolas for cross sections in two of the directions, but this is all one connected surface, and the other one we looked at before was really two separate surfaces. So this is a hyperboloid of one sheet.